Here we have a circle, an arc of the circle, and an angle standing on that arc with its vertex at the circumference. We know from the previous example that if we move this point around the major arc, the angle stays the same all of the time. We also have here an angle standing on the arc, but with the vertex at the center. Note the relationship here. The angle at the center is twice the angle at the circumference. If we change the arc, we change the angle. But note that relationship stays the same. The angle subtended at the circumference is still half of that subtended at the middle. And this will stay the same, however we change the angle by moving the arc. Twice 78.5 is 157. So the angle at the center is always double the angle at the circumference. So here we have a circle, and on this arc here we have an angle standing with its vertex at the circumference, and another angle with its vertex at the middle. We know from our previous discussion that the angle B is double angle A. If you're asked to give a reason, you should state angle subtended at center. So looking at this diagram, we can see that A and the 30 degrees stand on the same arc, but 30 stands at the circumference and A at the center. That means that A is going to be double 30, which we know is 60 degrees. Now consider this situation. The angles are both standing on this major arc. This one stands at the circumference. The other angle involved in the relationship is this one. If you're finding that hard to see, look back at the previous examples, and you'll see that it's always this one that's involved. We know this is 140, it follows that this would be 280. We know the angle all the way around a circle is 360, so B will be 360. Take away 280, which is 80 degrees.